Section 1.7, solving absolute value equations and inequalities. Remember, the absolute value of a number represented by x is written as the absolute value of x is the distance the number is from 0 on a number line. So for example, if we had the absolute value, if we looked at the absolute value of the number -4, we know that the absolute value of -4 is equal to +4. And if I looked at the absolute value of +4, that's also +4. So the absolute value of any number is positive. And remember, the absolute value is the distance that number is to 0 on a number line. So if I looked at a number line, and I look at the number -4, and I look at the number +4. The absolute value of -4 is +4, which is 4 units from the number 0 on the number line. And the absolute value of +4 is 4, which is also 4 units to the number 0 on the number line. In example 1, we're going to solve an absolute value equation. So in example A, we have the absolute value of 2x minus 5 equals 9. So we're going to solve this by dropping the absolute value that you see. Not going to change any of the signs of anything in the absolute value. It's going to remain as 2x minus 5. It's going to equal 9. And then we're going to also make it equal to -9 so that we can get all values of x that make the equation true. So if I add 5 to both sides, we see that 2x equals 14, and 2x will also equal -4. This tells me that x could be equal to 7, or that x could be equal to -2. And if you take the time to plug those two values back into the original equation, you'll see that both of those give us an accurate answer. For example B, again, we're going to drop the absolute value, and we're going to write the equation exactly as we see it. Do not change any signs. And we will make it also equal to -15. We're going to add 3 to both sides of the equation. And this tells me that x could be 3 to make that equation true, or it could be equal to -2 as well. Here we want to solve and graph an absolute value inequality. Both of these examples are less than examples. A less than equation is an and equation or inequality. So we'll look to solve this similarly to the equation that we just saw on the last slide. So we'll have 2x plus 7 is less than 11, and then we will have that it is greater than -11. We'll subtract 7 from both sides, and then we'll divide both sides by 2. And this tells me that x is less than 2, and it's greater than -9. So anything between -9 and +2, any value between -9 and +2 would give you an accurate answer for that inequality. For example B, this is less than or equal to, it's still a less than, so we'll copy this exactly as we see it, and we'll also have it be greater than or equal to -21. We're going to add 9 to both sides. And then we're going to divide both sides by 4. And this will be that x is greater than or equal to -3 and less than or equal to 7.5. So the solutions for this inequality will be all the values that are between and including -3 and 7.5. In example 3.1 with solve and graph an absolute value inequality. This is a greater than. Both of these examples are greater than. A greater than, I want you to think of as a great or. These are or inequalities. So they're going to look different than the and inequalities when you graph them. In order to solve an or inequality, again, we're going to copy this the way it's seen here. Don't change any of the signs that are inside the absolute value symbol. So we'll just keep this as 3x minus 2 is greater than or equal to 8. And then we want the or, which will be 3x minus 2, which will be less than or equal to -8. So you want to change both of those things, the inequality sign and the sign of the 8 that's there from a positive to a negative. So we'll have two things here. We'll have 3x. We'll add 2 to that 8, and that will give us that x is greater than or equal to 10/3, which means that x is greater than or equal to 3 1/3. And then for the second part, the or, we'll go to this and we'll add 2 to this number, this -8 here, which will give us -6. And that's going to tell me that x is less than or equal to -2. So here's our solution. We can represent this on a graph. Here's our negatives, positives. So if x is less than or equal to -2, that's a solid dot to the left. And greater than or equal to 3 1/3, so a little larger than 3, and then we'll go to the right. For example B, same idea, 3x minus 2 greater than 18, or 3x minus 2 is less than -18. So if I add 2, that's 3x is greater than 20. And that means that x is greater than 20/3, which means x is greater than 6 2/3. Or if I add 2, we have 3x is less than -16. X is less than -16/3. So x will be less than -5 1/3. So this will be an open circle. And this will be an open circle as well in this direction.